Hi, today my groupmates and I will be presenting topics about applications of enzyme. So I'll begin my part first with brief explain about enzyme. Enzyme is a protein that produced by a living organism which is highly specific and highly catalytic to its substrate. They play an important role as biological catalysts. Due to the action of enzyme, chemical reaction in organism can be carried out efficiently and specifically under mild conditions.
How enzymes can help. Environmental pollution rate has been increasing over the years due to the frequent release of hazardous and harmful substances. Enzymes have a great potential to effectively transform and detoxify polluting substances. They are also able to transform pollutants at a detectable rate and are potentially suitable to restore the polluted environments. Polyphenols, nitrile, heavy metals are high polluting pollutants. Decontamination is a process of removing a contaminant, which is like hazardous materials or chemicals or microorganisms. Enzymes are those decontaminating agents. This may be accomplished by physical means or even chemical neutralization or detoxification. How does this actually work is advancement in enzyme technology aid in developing the robust decontamination, detoxification, and protective agents against xenobiotic pollutants. Examples are enzyme immobilization and synthesis of enzyme nanoparticles. These enzymes can act intracellularly or even extracellularly. Example of the enzyme is lysis. Types of enzymatic classes used in remediation of polluted environment is hydrolase, dehalogenase, transferase, oxidoreductase. Producers of the enzymes are bacteria, fungi, plant, microplant associations. Example of bacterial hydrolases is carbamide or parathione hydrolases, which is from the Achromobacter pseudomonas, used in the transformation of pollutants. Example of carbohydrases are depolymerase, proteases, and phosphatases, which is produced by several bacteria and fungi. This is suitable for the transformation of insoluble materials, like plastics. Advantages of using enzyme as decontaminating agent is because they are low-cost, eco-friendly, manufacturers of all transformation, narrow or broad specificity, not inhibited by the inhibitors of microbial metabolism, used under extreme conditions, limiting microbial activity, and also applied to a large range of compounds in mixture.
The application of enzymes can be linked to these three Sustainable Development Goals, in short SDG, which are first, to create a sustainable cities and communities, second, to be responsible for consumption and production, third, to conserve life below water. We will be looking more details on how the application of enzymes are able to aid in achieving these three goals in the subsequent slides. As mentioned previously, enzymes save the environment from pollution, which they act as a detoxification and biodegradable agent, also as an ocean cleaner. So first, let us look to the oxygenase, that is belong to the oxidoreductase family. This enzyme can degrade the halogenated organic compound that result from the use of pesticide or herbicide. Lactase, which work in a similar way, is also used as a bioremediation agent to clean up the herbicide. This enzyme can also be designed as a biosensor that can detect the toxic phenolic compound, such as catechol. Both protease and lipase can act as a detergent, which can clean up the oil spills in the ocean. Protease can also use to degrade our daily green and animal waste that include keratin by convert them into biodegradable substance. Lastly, PETase, also known as a plastic-eating enzymes, which used to depolymerize the PET into smaller building blocks such as MHET, with its unusual ability to use PET as its major energy source for growth. After the overview of enzymes, we realized that enzymes are a powerful tools in achieving SDG. We are then able to maintain a sustainable environment through the use of enzymes in waste management. Hence, the adverse per capita environmental impact of cities can be reduced. A significantly reduce of marine pollution such as plastic and oil spills can be reached by 2050.
Before we end this, let's have a short recap on our presentations of the applications of enzymes. As we know that enzymes not only played a crucial role in our body but also contributed to our environment. Enzymes are well known to be highly specific, which binds to a particular substrate and result in a conversion into products. Other than that, Enzymes are biocatalysts in the environment which act as decontaminating agents to reduce the pollution of our environment. As you go through the video, it was mentioned that enzymes are environmental friendly due to their biodegradable characteristics. Furthermore, enzymes are low cost and helps to save energy as it is reusable and it will not be inhibited by microbial metabolism inhibition. Lastly, I would like to bring to your attention that the contribution of enzymes had aided in reaching the Sustainable Development Goals. That's all from us. I'm Ling together with Gayaatri, Yini and Nikki. Thanks for watching. Goodbye.